Hello friends, welcome to Electrical Engineers Convention. So today we are going to start a new playlist for the digital communication. So the first topic that we would like to start with is the sampling. Sampling is the basic process which we would have already discussed, but let's refresh the basics. So sampling is the process of measuring instantaneous values of a continuous time signal in a discrete form. In other words, when you make a discretization of an analog signal, it is called as sampling. So what we are going to do is we are going to take a continuous time signal. So let's say this signal is continuous on time. If you see the plot, you can say it is mapped across time and x and y-axis here could be anything. Here I think we can call it as amplitude. So this is a continuous time signal, and when we make copies of that in different instances of time, so let's say here it is xs of t, so x1 of t, x2 of t, and all the way up till xn of t. So what we are doing is we are taking the continuous time signal and making instantaneous values. We are making instantaneous values at certain instances like x1 of t, x2 of 3, all the way up till xn of t. We are just making it instantaneous and discrete at the same time. We are making it instantaneous and discrete at the same time in order to replicate back the continuous time signal. So the process of making this continuous time signal into a discrete time signal by measuring the instantaneous values in discrete form is called as the sampling. So how do we discretize a signal, or how do we convert a continuous time signal into discrete time signal? So in order to discretize, what we have to do is we have to have the gap. So if you see, there are gap between the signals, right? So the gap between the signals should be fixed. So let's say x1 of t and x2 of t should have a gap g1, so as x2 of t and x3 of t should also be g1. So the gap between the symbols or the signals should be the same. So if we achieve this, then it is called as sampling time, which means that the discrete signals are at sampling time intervals. So time is inversely proportional to the frequency, or if you just interchange, which means that the frequency is inversely proportional to time. So when you have a time setup like this where the gap between the signals are the same, then it is said to be at sampling frequency. So how do you determine the sampling frequency? Let's say that we have a signal x of t, as we already said. So let's say it is cos 2 pi ft. Let's say that this is the signal, and if you have to discretize this signal, how to find out the fs of this signal, that is the sampling frequency of the signal. So this process is determined by a theorem called Nyquist Theorem or the Nyquist Rate. So what the Nyquist Rate does is it determines what value of fs should be used in order to achieve a good sampling. So assume a signal with frequency components no higher than f of I. Let's say we are having x of t, which is cos 2 pi f I of t. So let's say this is a signal. Let's have another component on the same signal, 2 pi f low of t. So when comparing these two frequencies, the f of high is the highest frequency. So what Nyquist rate dictates is the sampling frequency should be 2 times that of the highest component in the frequency. In other words, f of s should be greater than or equal to 2 times that of f of high of the signal. So what happens if we have a sampling rate that is lesser than 2 times the f of I? So if f of s is less than 2 times the f of I, which means that the output signal when you get are cluttered over each other, so there is some intersection there. So this part of the signal cannot be recovered properly. So if you have f of s which is greater than or equal to 2 times the f of I. So if the f of s is equal to 2 times the f of I, we'll have a signal that are close to each other like this. If you are having f of s that is greater than 2 times f of I, we'll have signals which are separated by a gap. So which means that the signals can be easily recovered. In this case, it can be recovered, but it needs a sharp filtering. But in this case, it cannot be recovered because the signals have converged or went over each other. So we cannot recover the signal. So the way in which we have to discretize a continuous time signal is dictated by a theorem called as the Nyquist theorem or the Nyquist rate, and this process is called as the sampling. Thank you.